Hi, welcome to the second video of section 1.7, solving linear quadratic systems. So far, we've looked at linear quadratic systems, we've even solved one of them, and we've even done an example where we look to find the number of solutions or the number of intersection points that the system could have. So in this example, we're just going to take it a little bit of a step further, and we're going to see what an equation needs to be in order to just have one intersection point. So let's go ahead and get this one started. So it says if a line with a slope of 4 has one point of intersection with the quadratic function, what is the y-intercept of the line? So if you remember that demonstration we did with Desmos, we were allowing the line to move based on its y-intercept. And depending on its position, we had a certain amount of solutions. So we want to figure out what it needs to be so that we just have one solution. And then write the equation of the line in the slope y-intercept form. That's just y equals mx plus b form. Okay, all right, let's get this started. So we know our equation of the line has this form. The slope is 4, so it's going to look like 4x plus something. Okay, so I'm going to call this k. I know normally we call it b because it's the y-intercept, but we're going to be using the discriminant, and the discriminant has a subscript b in it as well too, so I don't want to use the same symbol. So we're just going to use k for the y-intercept. All right, we also know that there needs to be only one solution, so only one point of intersection. Okay, what that means is graphically, my quadratic opens up, maybe looks something like this. And the equation of the line needs to just touch once and just be tangent to the curve, okay, and only hit at one point. Okay, so if you notice, I just used the word tangent, okay? So when a line touches a curve at only one point, it is considered to be a tangent line. So tangent lines only touch curves at one point. So in order to get one point of intersection, our line actually needs to become a tangent line that touches at just that one point only. If a curve ever touches at 2 points, then what we've done is we actually created a secant line. So this is called a secant line. And it's because it touches at 2 points on the curve. Okay, tangent lines are special. They only touch at one point. It's kind of like they just kind of skim and they just touch at one single point on the curve. Okay, so in order for that to happen, in order for there to be just one solution, so we'll say this right here, in order for only one intersection to occur, the discriminant needs to equal 0. Okay, this means that b squared minus 4ac must equal 0. Okay, this is the criteria for only one solution. Okay. So let's go ahead. Let's get this started. So I'm going to write solution up here. Okay, so we're going to take our two equations. We're going to take this one, and we're going to take this one, and we're going to equate them. So we'll say equate both equations. Okay, that's step one. So we have a half x squared plus 2x minus 8. That needs to equal this equation here, 4x plus k. And it's okay, we're allowed to equate them even though we don't know the value of k. That is allowed. Let's go ahead and bring everything over so that it equals 0. So bring all terms to one side. Okay, so to do that, we'll subtract both sides by a 4x. That'll get rid of this. And then we'll subtract the k on both sides. That'll get rid of that. All right, so we have half x squared. 2x minus 4x, so 2x minus 4x, this gives us negative 2x. And then we have negative 8 minus k, that's at the end. And this equals 0. Now we're going to go ahead and we're going to solve for the discriminant. Okay. Not really solve for the discriminant. What we're going to do is we're going to set the discriminant equal to 0, like we have it here, and then we're going to solve for k. So let's write that in here. So this will be my a value, my b value, and this here, all of that, that's my constant term. That's going to be the c value and the discriminant. So we'll say set discriminant equal to 0. So we have b squared minus 4ac. When we set that equal to 0, we're basically saying there can only be one solution. So b is negative 2, and a is a half, and c is going to be negative 8 minus k. Negative 2 squared is 4. Negative 4 times a half is going to be negative 2. And then we have negative 8 minus k. We'll take care of this in the next line. We'll distribute in. So we have 4. Negative 2 times negative 8 is 16. And then negative 2 times negative k is 2k. Let's finish this up here. 4 and 16 is 20. So we have 20 plus 2k equals 0. So I'll subtract 20 on both sides to get rid of that. We have 2k equals negative 20. Divide both sides by 2. And we have k equal to negative 10. So therefore, the y-intercept must be negative 10 for there to be only one intersection point. So let's go ahead and let's check this solution. I'm going to go up here and I'm going to use Desmos. We'll plug in the quadratic. We have a half x squared plus 2x minus 8. Let's get that in the picture. And now we're going to put in our line. It was 4x plus k. So I know we calculated k to be 10, but we'll do that in a second. So I'm just going to put k here, and we'll say add slider. So we actually calculated a value for k in order for it to be one solution. We found that value to be negative 10. So if I set k to negative 10, notice that as it moves down, it gets closer and closer. At negative 10, we get exactly one solution. 2, 5, 0. That might be the x-intercept. Let's go to the next one. Yeah. That's our solution right here. 2, negative 2. So the question didn't say find the intersection point. It just said find what k needs to be so that there's only one solution. Okay, so what we did was we just equated both of the equations. Okay, we set them both equal to each other, and then bring everything over, and then set our discriminant equal to 0. Okay, if the question wanted to know what should k be so that there's no solutions, well then I would have made this to be a less than 0 symbol. Okay? If it wanted 2 solutions, then I would switch that to a greater than symbol. But it only wanted one solution, so I set the discriminant equal to 0, and then I solved for k. All right, that's it for this video. I'll see you in the next one.